So we are right now looking at cosine, which in the circle is showing the horizontal values, how they're changing as we go around the circle, as we change the thetas around the circle. Can you guys see this cosine cycle looks like a big valley in between the peaks of two mountains? Now when we look at sine, it looks different, but it kind of looks the same. Sine is a mountain into a valley. Now I can turn them both on at the same time, and this is in your module, so you could do this too if you want to go back and look at it. They're both on at the same time, so the theta values are exactly the same, the input values, and they have different output. What is this place right here where they both cross? 45 degrees, where they're both the same radical 2 over 2. And there's another place where they both cross right here, which is at negative square root of 2 over 2 in the third quadrant. But if you look at their graphs, they do look similar to each other. They both have a valley and a mountain. I'm going to turn off the cosine again. So the sine is a mountain, then a valley, and then the cosine, this is just one cycle. The cosine is one big valley. Now, next class, we will do the other four. If you want to look ahead, of course, you can look ahead, but next class, we'll be doing the other four. Guess how prepared I am right now? Not prepared. Now, this is still chapter 4 if you're putting your stuff in your folders. Okay, at the top, we just have some vocabulary. We've talked a little bit about this stuff. The first thing that I have is the period. Now, we have mentioned this period before. The period is how long one cycle lasts. Remember this circle, it goes around, but it can keep going around and around and around again and over again. So it could spin indefinitely. And when we take that and we put it on an XY axis and we make it rectangular, this could go on forever in either direction. The period is just how long one cycle is. It would be affected by a horizontal stretch or shrink. If I took that one period and I squished it in, it's going to be less long. If I stretch it out, it's going to be more long. So it's the length horizontally. The amplitude is the distance above and below something called the sinusoidal axis, which is my next vocabulary word. But it's affected by a vertical stretch or shrink. It has the exact same value as the vertical stretch or shrink. So what's the sinusoidal axis? The sinusoidal axis is the midline. I'm going to go back to that graph that was just up. Except for I lost which one I was on. This one here. So for this graph, our midline would be y equals 0. It is the equation of a line. Here, our midline, our sinusoidal axis would be where the graph goes above and then it goes below. It's that middle of the graph, y equals 0. The amplitude is how far above it and how far below it it goes. So how far above and how far below does this sine graph go? 1. That's the biggest number that sine could be, 1. So for the parent function, which we'll get to in a second, the parent function, it would be 1. A vertical shift is when we have a vertical translation, And then the words phase shift would be the horizontal translation. And you would just describe it like left for however much it goes. Then we have these two equations here. These are the transformation functions for sine and cosine. They're the exact same transformation functions that we were using in chapter 1, only it's for sine and cosine. What you do need to notice is that B is factored out it is after the word sine, so it is horizontal, but it is factored out of this horizontal translation. So it's the exact same rules that we had before. We just need to be careful about that we don't forget about the factoring. So we're going to graph the parent function. So these have no translations on them. To graph sine x, I need to graph certain key x values in one cycle that are easy to graph. And I also want to graph y values, which are the signs at those x values that are easy to graph. So when I go and I look at that app that I had open, the ones that I notice for sure that are easy to graph are 0, because it's 0. Pi, it's 0. 2 pi is 0. So those are really easy to graph. Now they have it divided out. They put exactly in between 0 and pi is pi over 2, exactly in between pi and 2 pi is 3 pi over 2. Also conveniently, what happens to sine at pi over 2? It's the maximum value. So that is a good one to have on the graph. And at 3 pi over 2, it's the minimum value. Notice how this does not look like a zigzag. So when we connect it, we're going to make a nice, smooth, relaxing wave. Nice, smooth curve, okay? Just hard to do. So I will always start with 0 to 2 pi. And if I forget what other values I start by, they are evenly spaced. So it's very easy for us. So halfway in between is going to be pi. Halfway in between 0 and pi is pi over 2. Halfway in between here is 3 pi over 2. These are the values that are on the quadrantal angles. These are the 1, 0, 0, 1, 1, negative 0. And then 0, negative 1. And because it's sine, sine is the y. Sine is the y, so I'm just using the y values. 0, 1, 0, negative 1, 0. So I just go around the circle and use the y values in those ordered pairs. So if you have forgotten what your y values are, you don't have to memorize the table. You just need to know this general picture of the 1, 0, 0, 1 stuff. Okay, and then we're going to plot those. And let's see, 0, 0. Pi over 2 is 1, pi is 0, 3 pi over 2 is negative 1, 2 pi is 0. And we're going to connect them with a nice smooth curve. Oops. Go away. Go away. There we go. For me, I'm like really bad at doing it when my computer is sitting up like this. But I have like so many cords plugged in. It's hard for me to face my computer a different way. If you have the ability of putting your computer flat, it's a lot easier to graph it. All right, that is one cycle. We will find a pattern and continue that cycle, because after it goes around the circle one time, it just goes around the circle again and again. So that pattern continues. After I have a mountain, then I have a valley. Guess what comes next? Another mountain. So I'm just going to follow the points. They're evenly spaced. I'm going to go all the way until I go off of the graph, and I'm going to put an arrow because it does keep going forever. Then I'm going to follow the points backwards. I just did a mountain, so my next thing is a valley. Then middle, then mountain, then middle, then valley, then middle. You see how it's a curve. It is not a zigzag. And that is the parent function for sine. Now we're going to do the parent function for cosine. Remember, cosine is the x values when we look at the ordered pairs. It's the x values. I'm going to still use 0 to 2 pi. But this time my x values are going to be 1, 0, negative 1, 0, 1. And then again, this is a smooth curve. I don't like trying to do this at an angle. That's better. All right, so that's one cycle. We can see that valley in between the two mountain peaks. And then from there, I'm just going to follow my pattern. So where I'm at the top of a mountain, then I have to go middle and then valley. Or if I'm at the top of the mountain, middle, valley, middle, mountain, middle, valley. At the edges, when this goes off the graph, make sure that your teacher can tell that you know that it's going to come up next, that the arrow doesn't point down, because it would just turn around right there and go back up. And that's what cosine is going to look like. So you can see, again, sine and cosine compared to each other. They look really similar. They both have that same smooth arc shape. They're all same distance because they have those same numbers repeating. They're just in different places. But when you look at just one cycle, they have a different shape. It's a different part of the graph. So before we actually graph these, let's look at just some that are graphed, and let's talk about the period and the amplitude. So to find the period, we're going to start with our period of the parent function, which is normally 2 pi. It's normally 2 pi. This question has transformations on it, and what will affect the period is a horizontal stretch or shrink. So here I do have a horizontal stretch or shrink. What do I multiply by if it's a 2? We would multiply by 1/2. We do the same thing to the period. Because it's a horizontal stretch or shrink, it will shrink the horizontal distance of that period. So our period for this one is pi. Now you can actually see that this is a sine graph. So it starts at 0, 0, and then it goes up, and it goes down again, it comes back to 0. And then you can see that is exactly pi long. So you can see it as well. I'm just going to do it using transformations when I find the answer. And then we have to do our amplitude. And the amplitude, I told you on the first page, is the vertical stretch or shrink. It is the definition of it is from the sinusoidal axis, which is the midline, how far above and how far below does this graph go? And the answer comes from the vertical stretch or shrink, which is 3. So that's the amplitude. So the next one, period. We're going to start at 2 pi, and then we're going to use a horizontal stretch or shrink. So I'm going to multiply 2 pi by 1/3, and our period is 2 pi over 3. Our amplitude is how far above and how far below. So I could look at the graph and figure that out, or I could look at my vertical stretch, which is 2. I'm going to stop talking because I want you to kind of work ahead of me and see if you can answer these before I write them down. Don't worry, I'll write slow. Lauren, did you figure out the period yet? Okay, how'd you get that? What'd you multiply by? Okay, which 3 did you use? The x over 3. So she's actually using that 1/3 multiplying by its reciprocal, which is 3, and 6 pi is correct. Thank you. And who do I pick on? Just kidding. Sanjay, did you get the amplitude? 3, which 3 did you use up there? 3 is correct. Which 3 did you use? This one here? That is not the correct 3 to use. The answer is 3. Which 3 should he be using? Emily, do you know? We're going to use the -3, but why is the amplitude not negative? Because it's stretched by 3. Why is it not stretched by -3? Okay, somebody else said it. Somebody said reflection. Who was that? Oh, Madeline. X, the x-axis, yes. This is a reflect in the x-axis. Remember, if we have a negative sign, it's a reflection. So the amplitude is never negative. It's a distance. Like it goes up 3 or it goes down 3. So now these don't have graphs, so you do just need to use the equations. Hopefully you're working ahead of me. Oops. Tyler, period. 4. Yeah, I'll come back to you. Vivian, amplitude for the 4th one. It is 1/4. All right, Tyler, I'm back. Sorry, I rushed you. It would. So that is 1. Yep. It's kind of weird. It's okay. So it would be like 1.0, where pi would be 3.14. I said, oh, that really bothered me. 1.0. All right, next one. Abby, period. How'd you get it? 10 over pi, and she got 20. That is correct. Abigail, amplitude. 2/3. Good. Deep, easy stuff. All right, the next we're going to describe the relationship between f and g. We're not even going to get that detailed in it, but f is the parent function. And then g would be the transformed function. So really we're talking about transformations, but we want to use words like amplitude, period, some sort of shift. Okay? So instead of saying something like vertical stretch of vector of whatever, you're just going to tell me the amplitude is. Okay? So for the first one, we have the parent function as f, the new function of g. And Eden, can you describe how G made it different? Like what's different about G? G is the, can you see the one I made blue? G is the black one. So opposite. It's not like this. I know, I'm just cold calling on you guys. You're not ready. This one's G. They both have the same x-intercepts. They both hit their minimum at pi. They both hit their maximum at the same place. But how are they different? It's taller and lower at the same time. So it's like we took, look, we took, oh gosh, I need a third hand. We took a rubber band that was like this. This was a good idea in my head. And then I did this to it. That was not a good idea. Okay, so we, okay, and then we did this. So like my fingers are staying put. The rubber band was here, and now it's like this. What's happening? What's happening to my rubber band? I'm stretching it, right? This is a vertical stretch. That's what's happening, Sarah. Is that affecting? This is the amplitude. So we've got an amplitude of, and then what would the value be? Anybody? 2. Good. All right, the next one, the f function is the parent function, which I'm kind of highlighting here. And then the g function is the dark black one. So maybe I'll call on somebody if they're ready instead of just picking. Somebody who's not ready, sorry, Eden. If nobody's ready, I'm just going to call on somebody. I'm not going to sit here for minutes waiting. Jacob. It is a horizontal shrink. I don't think it's 2, but so let me just look really fast. Jacob, do you know which function this is? That's the cosine, good. And then from start to finish, if I'm looking at the shrunk one, here's one cosine, and then another cosine, and then it looks like one more will fit. So there would be 3 of them. You see how I took this first blue one and I divided it up into 3 of those smaller cosine ones. So it'd be a shrink. So that would be like a shrink of 1/3. But when we talk about amplitude, period, or shifts, if I'm talking about a horizontal shrink, who can tell me what that affects? And if you're sleeping, I'm definitely calling on you. Madeline, did you want to say? It does affect the period. So instead of the period being 2 pi, what would be the period of this one? It would be divided by 3, or multiplied by 1/3. 3 of them fit within the original 2 pi. Okay. Yep. Sure. You're not going to really write this stuff in your assignment. This is just us warming up to what it looks like. And like in your assignment, it'll be less formal. It'll be period equals blank. You write 2 pi over 3 on. All right, the next one, the original function is f. I'm highlighting it in blue. Not all of it's shown, but. And so G is the new one. Does anybody feel comfortable talking about this one? Or if you're falling asleep, I'll call on you. By the way, if you are tired, because my room seems to be toasty today and it's the end of the school, and I know you're like having so much fun, but I guess sometimes that puts you asleep. You can stand at my counter. That's totally there available for you to stand at. I have people that go up there every single class, so don't feel like you can't do it. People do it every class. Okay. Brandon. It is a horizontal translation. Now, when I go back to the very front of the very beginning of this, there was a horizontal translation, but they call it something different. A phase shift. So it's a phase shift. So I'm going to look at F right here, and then I'm going to look at G right here, and that goes which direction? So I will say right. It is in the equation, which I'm not writing the equation down, but in the equation it would say minus, yeah. But we're literally moving it to the right pi. Okay. And then the last one, this is F. We need to talk about G. Anybody want to take this one? Ava, take it. Okay, it's a what shift? Okay. Well, I think you said amplitude. Right, so amplitude, look at the amplitude example. The amplitude is going to have the same x-intercepts. It's just going to be stretched. So these do not have the same x-intercepts. It's a vertical shift. By how much? Yeah, 2. Good. All right, now we'll actually do some examples. So when I go to do the examples, first thing I need to do is fill in my table with the parent function points, which we already put on the first page. But if you have forgotten them, you don't have to keep flipping through the page. I would rather you have some way to remind yourself of them rather than looking at something that is not memorized. So if you need to draw this, then the sign values are the y values in that unit circle. So again, if you have to keep flipping back in your notes, you're not actually necessarily remembering it, you're just looking at it written down. To remember it, you have to be able to connect it to something you already know, which is graphing ordered pairs around the circle 1, 0, 0, 1. So the y values around that circle are going to be 0, 1, 0, negative 1, 0. So that's my parent function. Now we're going to do transformations. I don't have to write them down. I'm just talking through them. You don't have to write them down. What's this 2/3 do? Do we have to factor it? I don't have to factor it before telling what the 2/3 does, but since somebody said, wait, we got to factor it, I'm going to go ahead and do it right now. If we have to factor that out, we're going to have x minus, and to factor that out, we have to factor it out of pi over 6, and factoring is dividing it out. So I have pi divided by pi over 6 divided by 2/3, which is the same thing as pi over 6 multiplied by 3 over 2. Which is pi over 4. Now, what does the 2/3 do? Transformations, what's it do? Patrick, what's it do? So it is written as part of this sine function, so it's not vertical. What am I going to multiply by? 3 over 2. So is that a stretch or a shrink? That's a stretch, right? So we're going to multiply all of our x values by 3 over 2. And I am doing this somewhat fast because I want to get done with these notes faster. But when you go do it on your own, you have to know how to multiply fractions. So I got 0, 3 pi over 4, 3 pi over 2, 9 pi over 4, and then 3 pi. Then we have this minus pi over 4, which becomes a plus pi over 4. So this is moving it to the right, pi over 4. And again, you need to know how to, I see squinting. Let me zoom in. You need to know how to add, subtract, multiply, divide fractions. So I'm going to go a little fast because I learned that a long time ago. So 3 pi over 4 plus pi over 4 is 4 pi over 4 pi. And then we get 3 pi over 2 is 3 pi over 6 pi over 7 pi over 4. And then 10 is 5 pi over 2. And then it is 13 pi over 4. Is that what you guys got? Okay, so now when I'm looking at my values, there might be some values on there that I'm not very familiar with because they don't show up on my graph very easily. And they're fractions. So I just want to remind you that all of these are evenly spaced. So the first one, pi over 4 is 0. Pi over 4 is exactly in between 0 and pi over 2. Pi over 4 is 0. My next one, pi, is at 1. That's easy. Now 7 pi over 4. So I might not know where that is. So I'm going to show you two ways I could figure it out. First way is 5 pi over 2 is on this graph. So 5 pi over 2 is my next one at -1. See, my next one is 5 pi over 2. So I kind of skipped one. These are evenly spaced, so it has to be exactly in between these two, but at 0. So if I know the 2 around it, I could find the 1 in the middle. Another way that I might use to figure out where these are, because they're evenly spaced, is I might just count how many blocks, how many units they are spaced horizontally, and it looks like it's 1.5. So I don't know where 13 pi over 4 is, but I'm just going to go from 5 pi over 2 and go 1.5 units away. And that's where it should be 0. They should look evenly spaced. If not, you're doing something wrong. And then once you get those graphed, you're just going to continue that pattern. They're all 1.5 blocks apart. So I'm going to continue 1.5 blocks apart and make sure I have a mountain, then middle, then a valley, then middle. I'm going to darken in my original one. You don't have to darken in your original one. I'm just doing it because you guys are learning. And then the rest of it was just me finding the pattern. So the period of this, normally 2 pi, but we had a horizontal stretch or shrink. We had a stretch of 3 over 2. So now our period is 3 pi. And if you look at the graph from start to finish, one cycle, if you count how many boxes that is, that ends up being 3 pi. Amplitude, did we have a vertical stretch or shrink? So the amplitude is 1. It is not 0. It's how far above and below the midline it goes. Sinusoidal axis. That is the midline. And for this one, it did not change. We did not have a vertical translation, so it's y equals 0. If it doesn't change, it's y equals 0. The phase shift is the horizontal translation, which went plus pi over 4. We write the words right pi over 4. That's like you writing your transformations out. Notice how I'm not asking you to do that because you're just putting it in this information here. The domain, we're going to write in interval notation from left to right. What happens with this domain? What x values can we have? Okay, so that in interval notation is negative infinity to positive infinity. Thank you, Gracie. And then the range is from down to up. So we go from lowest value to highest value. interval notation. Starts at -1, ends at 1, brackets or parentheses? Brackets, because it does equal. Okay, now we have a cosine. I put the table for this one off to the side so I could have space so it fit into one full page. So I'm going to start with my cosine. My cosine is the x values for this thing that's at the top of my page that I don't want to keep scrolling. It's the x values. So the x values are 1, 0, -1, 0, 1. Transformations. We have a -2 in front. That's a reflection and a vertical stretch of 2, but we can do all of that in one step. -2 multiply on the y side. Then we have a +3. So that is a vertical translation, up 3. Inside is this one that I would need to factor. Yes, I do have to have that 2 separated from the x plus translation. So -2 cosine, I'm going to pull that 2 out. I still have x plus pi, and then +3. So I'm going to multiply my x's by 1/2. And then I'm going to subtract pi. And I know I did it fast. So at -pi, I'm at 0. -3 pi over 4. So if I didn't know where -3 pi over 4 was, I might skip it and graph -pi over 2 at 5. That would mean that -3 pi over 4 at 3 was exactly in between those. I've done something wrong because that's not 0. This is at 1. Sorry. There we go. So since this is a cosine graph, oh, that was so ugly. This is a cosine graph. It's going to have that one valley as its original points, but it's reflected, so the valley's actually a mountain. And then I'm going to finish it by continuing that pattern. I'm going to walk around while you guys are graphing this because I want to see what your graphs look like, just make sure that they look like you're doing the right thing. You can fill out that information, which I will put up when we're done graphing. All right, so the period. Did we really stretch or shrink this? By what? 1/2. So now our period is pi. Amplitude. Did we have a vertical stretch or shrink? We did. What did we multiply by? 2. The answer is not -2. It's 2 because the negative is a reflection. sinusoidal axis. The sinusoidal axis is that midline. So these graphs are called sinusoids. Sinusoids. Both, even the cosine graphs called that. Okay. So the sinusoidal axis is always y equals, what does y equal? 3. It is that vertical translation. 3. Phase shift is the horizontal translation, which was left pi. Domain is all real numbers, so negative infinity to positive infinity. Range goes all the way down to 1 and up to 5. All of that information I can get from the equation and table. You don't need the graph to get all that information. You can use the graph. Why is it brackets? Because if I have a value that actually is that value, then it will have brackets, like it equals to. And everything in between. All right, we are on example 5. For this one, we're not graphing it. We're just finding period, amplitude, sinusoidal axis, and phase shift. And then find 5 key points. So to find those 5 key points, we will use the table to do the transformations. We notice this is a cosine, so that will be cosine starts at 1, 0, negative 1, 0, 1. We have a 4 in front, so multiply the y's by 4. We have a minus 5 at the end, so subtract 5 from the y's. What do I multiply my x's by? Okay, so the answer is not 3. And now I can't really understand what people are saying. No, it's not 1/2. So it's whatever's in front of the x, which, by the way, I still have to factor out before I can find the last column. I still have to factor that. But whatever's in front of the x, pi over 3, I have to reciprocate that. So we're going to multiply by 3 over pi. It is okay to multiply by 3 over pi because pi is not a variable. It is a number. Now, I do need to factor that out to find the next column. So 4 cosine pi over 3, parenthesis, x minus. So if I take 2 pi over 3, and instead of dividing by pi over 3, I'm going to multiply by 3 over pi. I get 2. So I will add 2 to the end there. So multiply by 3 over pi, I get 0. 3 over pi, I get 3 over 2. I get 3. 9 over 2. 6. These are evenly spaced. We're adding 2 to each of those. 2, this is 1.5, so 3.5. 5, 4.5, 6.5, 8. It says to find the 5 key points. You do not need to list these separately unless I have you type it in Canvas. But if I were going to list them separately, it would be like 2, negative 1, 3.5, negative 5. 5, negative 9, 6.5, negative 5, 8, negative 1. But I don't feel like you need to list those separately. If you know where they are in the table, you'll be fine. All right, period. Normally 2 pi multiplied by 3 over pi What's our period? 6. Amplitude. What's amplitude? 4. Sinusoidal axis. Normally y equals 0, but then we have a vertical translation. So now it's y equals -5. Phase shift. Right 2. Correct. If I were going to graph this, I would not want to graph it on those graphs that have all the pi's on them, because look at my x, y values. They're just like normal numbers. What made them normal numbers? Yeah, because when we multiplied that, ooh, would that be a stretch or shrink? It is a shrink. It's barely. Because 3 over 3.14, the bigger numbers on bottom, it's barely a shrink, but it's a shrink. When we multiplied that, it canceled out the pi's. All right, last section is with the calculator, and I'm going to show you some stuff that maybe is new on the calculator to you. What I want you to do first is go to your, and I'll have it up here too, go to your y equals and type in the equation, that equation that it gave. Oop, come on. There we go. Got this microphone cord right here. Type in the equation that is on our notes. Find it real fast. Your type equation right here. Two plus 5 cosine pi over 10, parenthesis x minus 3. If you have the newer calculators and you've forgotten how to make a fraction, you do alpha y equals. That gives you a fraction, alpha y equals. If you have the older calculators, you're just going to have to do parentheses with a division sign. We're not graphing it yet, though, so don't hit graph yet. Just type it in. I forgot to tell my other class this, but and I'll have to look and see how you guys do it, but there is now a graphing calculator app that you can download onto your Chromebooks. So if you forgot your calculator that day, you could still use your graphing calculator on your Chromebook. Okay, so all I'm doing is getting this typed in, and go to the calculation screen, but make sure you're in radian, because I'm in radian mode. So if you're not in radian mode, we're different answers. So the first on the worksheet, on the notes, says, find the given function value, f of 7.8. To show you how to do f of on the calculation screen. Okay, I'm going to show you how to do f of on the calculation screen. Are we ready to go on? So this next thing I say, you might have to write it down so you can remember how to do it. You're going to go to vars, V-A-R-S, vars. And then you're going to go over to y vars. And you're going to choose number 1, which is function. And we typed our equation into y1. So I'm going to hit y1. So instead of typing in f of 7.8, I'm actually going to type in 7.8. See how I typed it in? And then you guys can hit enter. The answer, 2.3140. 2.314. Yep. Let me show it one more time. So again, I went vars, then I went to y vars, function, And then there's my y1. And 7.8. So it's the same thing as doing f of, we just don't have an f, we have a y instead. I'm in radian mode. Are you in radian mode? Not getting the right answer? Is it possible you typed it in wrong? I can look at it. So it looks like your ending was after the cosine, and then this looks like it's multiplying after that. So you need to not have this here. Right, so you could have that there, you just need another parenthesis. So you don't, this thing, sorry about that. Having calculated. So you're either in the wrong mode or you typed it in wrong. I can fix it if you typed it in wrong. Back to the questions. The next question is find the first positive values of x for the given 6. And then after that, then it says you're going to verify this answer by graphing. So notice how I haven't graphed yet because that doesn't come till question C. So we're going to do this somewhat by hand. You will need the calculator to find part of it. We're going to do it somewhat by hand. So if we are finding where this equation equals 6, I'm going to have 6 equals 2 plus 5 cosine pi over 10 x minus 3. Now we are solving for x. We're going to get x by itself. What would I do to both sides first? I'm going to subtract 2 first. I'm going to get rid of the vertical translation. I'm also going to get rid of another vertical thing. What's the next thing I'm going to do? Divide by 5 because we're going to undo that, whatever that thing is called, vertical stretch. So now I have 4/5 equals cosine pi over 10 times x minus 3. What's the next thing I'm going to undo? I have to undo cosine next. What undoes cosine? Inverse cosine is the only thing that undoes cosine. The only thing that undoes it is inverse cosine. So to both sides, I'm going to inverse cosine. Now, I'm not typing in my calculator yet because I know I'm going to have to type other stuff in. I'm just going to write inverse cosine 4/5 equals, now that cancels the cosines on that side, and I get pi over 10 times x minus 3. Now I need to talk off of, like, stop what we're doing here and just go talk about something else and then come back to it, okay? When we were doing this inverse cosine on our last test, on our last section, when we did inverse cosine, if we did that to 4/5, that's a positive number. How many answers did I get? I got 2 answers, but I got an answer in the first quadrant, and then I also got an answer in the fourth quadrant. That's where x, cosine, is positive. But I only got 2 answers because specifically you were told only between like 0 and 360 or 0 to 2 pi. Because otherwise it could keep going around as many times as we want. I do not have a limit on how many times we're going around here. So when I did inverse cosine and I found 4/5, or inverse cosine 4/5, there's actually more information I need to write there. So the first thing I'm going to look at is, so for the inverse cosine 4/5, if I did that on my calculator, that would give me this one right here, the angle right here. But I also need this one. How could I get this other one? Okay. So I am going to use 2 pi. I'm going to use 2 pi. But before I get there, I want to show you something right here. If I add whatever that angle is, I'll go up. If I subtract that angle, I'll go down. So instead of worrying about 360s and pi and 180s and all that stuff, if I just add or if I subtract, I'm going to get both of those answers. So what I'm going to write over here, I'm going to write over here is just plus minus cosine inverse 4/5. So that's going to give me 2 answers. But I need infinite of those 2 answers. So for those 2 answers, how could I get another answer that is coterminal with those? What would I do to get another answer that's coterminal? Was on our test, coterminal. What do we do? Add or subtract 2 pi. It doesn't really matter what we do. But since we are looking for positive values, I think I'm going to use the addition of 2 pi. But I'm not just adding 2 pi because I want it to go around infinite amount of times. So I'm going to add a certain number of 2 pi's. But I don't know what that number is. So I'm going to put a variable. I'm going to add maybe k 2 pi's, 2 pi k's, 2 pi k. Will that work to get any coterminal angle? Ooh, somebody tell me who's talking because I can't. Christopher? K has to be an integer. Right. Can k be 0? Yes, because if k is 0, this thing's not here, and we just have what we were going to have anyway. If k was 1, that would work. If k was negative 1, then we'd be subtracting 2 pi. That's probably not the answer we need, but k can't be a half. So it can only be integers. So to say that, you could either write, and I'm going to write this off to the side here, you could either write that k is an integer, or you can use the mathematical shortcut to say that. And the mathematical shortcut, I'm going to write in quotations, but then I'll write the symbols for it as well. And I'll write the symbols first. The symbol, I'm going to put it down here. The symbol is K, and then it's got this kind of curvy E shape thing. I don't think I did a very good job of writing that. And then the symbol for integers is that Z with the double line in the middle. And what that reads is that K is an element of the set of integers. That's what that is saying. So you can write out K has to be an integer, or if you learn this shortcut way of saying it, that could probably apply to other things later too. Wink, wink, nudge, nudge. Okay. All right, I'm sorry. That equals pi over 10 times x minus 3. I really maybe shouldn't have put that right there. Okay, so we're still solving this. We still don't have x by itself. Let's go back to solving this. What do I do next? Multiply both sides by what? 10 over pi. And multiply both sides by 10 over pi. See, so on this side is going to give me plus minus 10 cosine inverse 4/5 over pi plus, and when I multiply this by 10 over pi, I get 20k. On the other side, I have x minus 3. Almost done. We're going to add 3 to both sides, and we will get 3 plus or minus 10 cosine inverse 4/5 over pi plus 20k. Okay, we now have x by itself. So now we're going to use our calculator. So grab your calculator. If you have the newer calculators, to get the fraction, y equals, enter. Calculators, you're probably going to need an extra set of parentheses around your numerator to type it in. Which one? Yep. Alpha, y equals, enter. There's even a shorter way of doing it, but I can't remember what it is. It might just be alpha x, and now I got to find out. X is the shorter way. Okay. All right, so we're typing in 3 plus 10 cos over 5 over pi. I'll type it in. Now I can't, well, I can right now 0. So I'm adding 20 times 0, and I get this answer. To do another answer, I'm not going to retype that in. I'm going to hit second enter. Oops, I'd hit the wrong thing. I'm going to hit second enter, and I'm just going to go change that plus sign to a minus sign. So I don't want to retype it all in again. And I get these two. So my goal is to have the first 3 positive answers are both positive. So I've got 2 positive answers. If I took away a 20, would I still be positive? So these are the first 2 positive answers. So I got 0.9517. I got 5.0483. And now we have to use this 20k, where k is just integers. So I've already used 0. I don't want to go negative, so I'm going to go with 1. Which number should I add 20 to? 20 onto? The first one or the second one up here? Yeah, the 0.9, that's the one I'm going to add 20. If I add it to the other one, then I'm getting the 4th. So I don't need my calculator to do that. I'm just going to put 20.9517. Should be my third one. All right. So we did that. Okay. Now we're just going to check our answers with the calculator graphing. Okay, so we're just going to make sure that it all works. And so we're going to turn to our graphing calculator, and it says what to do on there, but like it'll say on your assignment as well. It says make y1 the function, the f of x, make y2 what it's supposed to equal 6. And before you go and just hit graph, we want to think about what our window look like. So if I'm looking at the answers that I got and thinking about my amplitude, let's see, where's my equation? I'm just going to look right here. It's written here. When I talk about what my window should be, we are multiplying the x's by, oh, that just stretches it out. To look at the window for the x's, I'll probably look at my answers. how low should I have and how high should I have so that it will definitely have these three answers in there? What should be my minimum X value for my window? 0. How about -2? Let's go just a little bit lower. Just to go a little bit lower. I mean, you could totally do 0. It's up to you. Let's do -2 to what? What's something good that's above this? 20 what? 22? Okay. Now, if you do not have the 20 point whatever in the window, you won't be able to find the answer when we do what we're about to do. Like, it has to be showing. Okay, and then how about the Y's? So we had a +2 added on here. That's not very far up. There was a stretch of 5. So where it normally go up 1, down 1, up to 1, down to -1. Now it would go up to 5, down to -5, but then we added everything. We added 2 to everything. So what would be a good window for the Y's? That amplitude is 5. So that means it's going up 5, down 5. But there is a 2 vertical translation, 2 up. So if it normally go up to 5, this one's going to go up to 7. So something more than 7. 8, 10. How about 0 to 10? That's an easy one. 8 is fine. I'm going to do 0 to 10 because I think that's what mine already says. I don't remember what mine says. So X, we're doing -2 to 22. Oh, I didn't have 0. I had -5. Ooh, that's not going to work. 0 is not going to work. Because if we're down here at -5, and then I added 2, that's -3. Yeah, but I want to have like a little bit of buffer room in there. So how about -5? That's what I had before. Oh, you guys can't see what I had before. So -5, we'll do -5. All right, so once you have your mins and your maxes put into your window, then you can go ahead and hit graph. And then take a break because it takes forever to graph. All right. Just mine? Yeah. That's interesting. Okay. All right, so now this is how I would, there's different ways of checking it. This is how I would check it. I'm going to use this calc button, which is second trace. And I'm going to choose intersect 5. It's going to ask for first curve. I only have 2 things typed in. So if it says first curve and I hit enter, it's going to say second curve and I hit enter, I'm fine. Now, if you got more than 2, then you got to be paying attention to what it's sitting on. Then it says guess. There are 3 places. It will only do 1 at a time. So I'm going to tell it where to look. And our first answer that I think we should have is what? About +1. So I'm going to have it look near 1, and I'm going to have it do that by typing in, when it says guess, I'm going to type in 1. See how it pops up at the bottom? So I type in 1, then I hit enter. 5, 1, which is the answer that we got. So I'm going to do that again. Second trace, intersect, and for round 5, when we wrote it on our paper. So I'm going to guess around 5, and is 5.048. Sorry, I had written down. One more time, second trace. This is the one I was most nervous about. First curve, yep, second curve. Now this one. So I'm going to type in 20. And it told me 27. Is that what I had? All right, then I did it right. Okay, so that's all you have to do for step C. You guys have, there's 2 separate worksheets because normally this would be a 2-day process, but block day. There's 2 separate worksheets. The quiz that you're going to expect will not be on the second worksheet. It'll be on, you see right here. Oh no, it's not right here. It's on the week at a glance. It will just be on the first worksheet. I didn't even put it on this at all. I'll put it on here. It will not be